how many needles and how many intersections. Okay? So we're going to speak in English to accommodate those who don't know Hebrew. This is an experiment that was performed by the Comte de Buffon, which is the Count of Buffon. His name is Georges Louis Leclerc, right? He did an experiment where he took a needle, it's called Buffon's needle. He drew lines on the floor. He had a big house. He drew lines on the floor, and then he would throw a needle. So he would take something like this, and he would throw it on the floor like that. Okay, and he would count how many lines it intersected. Now you can ask, which lines do I mean? Do I mean the horizontal or the vertical lines? Soon we're going to use both, because that's what's drawn here on the floor. But if you were talking about the vertical lines, then I don't know if you see this, then this needle intersected a vertical line, so I count it as one. And if it would have landed in the middle of one of these, in between two lines, so it could land like that, it could intersect the line, it could land in between, it could land at any angle, right? And I can count 1 or 0 if it intersects or doesn't intersect one of the lines. And why did we do this? Well, I want you to notice this is a very, very unique experiment. We don't need any measuring apparatus. We just need to look at the experiment. It's much easier than many experiments where you need to measure things and you have to be careful and everything. You just need to look at this. And in fact, what you'll get from this is a number related to pi. So we can calculate pi using this experiment, and I'm going to explain first the math behind it. This is a simulation of little needles that I've thrown here. There are, I think, something like 400 needles. No, this is probably less. And on a tiled floor like this one. We're going to soon do this experiment by hand. So today this is experimental mathematics. We have applied math, right? So I did a simulation. We throw, and you see the needles are colored because when you have a square tiling and not just horizontal lines, then you can intersect no lines like the light blue arrows or needles, and you can intersect 2 of them like this red one, or just 1 of them with the blue one. So you have to count how many times each needle or each stick hits a line and how many lines it hits, okay? So let me do the experiment. This is a twist on the original experiment, but this is a beautiful proof by Barbier. Okay. But anyway, so here's the proof. Suppose you have this square grid. I throw in a stick on the floor here, which we're going to do soon. Okay, so I throw in a stick, and I want to ask how many lines of the tiling does the stick intersect? Okay, and since this is a random thing, we're going to take expectation. So how many does it intersect on average? Now, we have to define, if this stick was very, very long, of course, it would intersect many, many things. Stick is going to be of length L, and the side length of the square is going to be of length S. L is at most S, so it doesn't intersect more than 1 line in the horizontals and more than 1 in the verticals, but it can intersect 2 of them like that. If it lands near a corner, it never lands on a corner, although in practice it does, of course, because we have thickness. But if it lands on a corner, we're going to count it as 2, not as 4 or something like that, because measure 0 actually. So, okay, but let's do the expectation of the stick of length L of the number of lines that it hits. Okay, so let's start with the case L equals 1. And we call this expectation E1. E1 is the expectation of a line of length 1. The side length here is S, general. Okay? So this is the expectation of the number of lines that it hits. Now, what you can see is, suppose I took 2 such sticks and threw them, right? Then their expectation of the number of lines they hit together is just the sum of the 2 sticks, right? So you get linearity of expectation tells you that it's E1 plus E1. Expectation is linear even if the variables are not independent. So you can add sticks even if you tape them together. Even if you connect them, each one itself intersects lines, right? And has some average. And the average of these two sticks together is just the sum of the averages. So even if I draw a polygon here, doesn't even have to be a regular polygon, any shape that I get, right? This is just many, many, many sticks. If I sum the lengths of these things, right? So I can get that the expected number of times this thing hits is just the perimeter times E1. Okay? That's the expected number of times it hits from linearity of expectation. But now, let me give you a special polygon. Okay? We're going to take a circle whose radius is exactly s over 2. Okay? Now, first of all, I want you to notice something about a circle like this. This circle, at any place I put it on the grid, is going to intersect exactly 4 points. Right? No matter where I put it, even if I put it exactly in the middle of the square, it's going to have 4 points. If I move it, it's going to intersect 4. Right? So it's going to have exactly 4 intersections. So the expected of C, which is for the circle, right, of radius, let's write here, s over 2, is exactly 4. Right? Because it's a constant. It's not even a random thing. Okay? And now, what I can do is I can bound this by some polygon. If I bound this with some polygon, say Pn, which has n sides, right? Right? Then, as close as I can, then I get that this is at most the number of intersections of this P upper n. Right? This is not a power, just upper n. Okay? And it's also at least expectation of P lower n, right? If P lower n is, some polygon which is bounding on the inside. And when I let n tend to infinity, I know what the perimeters of these two polygons will be, right? It just tends to the perimeter of the circle. And since I sandwich this 4, I get an equation. 4 is equal to 2 pi s over 2, which is the perimeter of the circle, times E1. So I know what E1 is. So now we know if I put this stick of length L, then I know the general formula, because so if I have L, then I know that the probability, the expected number for my length L stick, SL, say, this is going to be just L times E1, which is 4 divided by pi, and here I have to divide by S. So you see, of course, the only thing important is the ratio between L and S. We expected that to happen, right? The length of the stick and the side length of the box, and 4 over pi is the number. So if we compute this number, then we can rearrange and get pi. Okay, so this is this simulation. Here L, I've taken L to be 1/2, and S is 1. Okay, so here, throwing the needles, tuck, tuck, tuck. Okay, see how they're appearing and jumping all over the place, and you start counting them. And basically, to get this expectation, what you do is you sum up the number of intersections, right, of all your needles, and divide by the number of needles. Okay, that's all. That's to get this expectation. All you need to do is just this is law of large numbers, so it's not equal, but it's roughly equal, right? You need a very, very large number of needles to get a good thing, because the standard deviation is going to be square root. So it's not so great. It's not a great approximation of pi. So I already did this for you at home, and I did 10 to the power 8 needles, okay, whatever that comes out to be, and I got pi is equal to 31416, which is pretty close. I think it doesn't be. I think I got lucky. I think it should be 314 is already really good. Okay, so this is not a great approximation. Okay, so you ready to do the actual experiment? I need some volunteers to come and help out. I'm going to throw these needles. We're going to count. We're going to write down how many intersections there are, and sum them and divide by the number of needles. How many needles and how many intersections? Okay. Shalosh, Arba.
7.
לא יודע את המימודים הזה, לא יודע מה יש לך. רגע, מה זה?
כמה זרקת?
So it's actually easier to first pick them up and then count how many you have in your hand. So how many did you have?
14 פלוס.
Okay, איתן?
אני לא יודע לספור. 15-3 יצא. לא חתכו כלום.
רובם לא חתכו כלום?
גם יוצא רובם. אז מה קיבלת שם?
אין מצב מה שאמרת. איתן?
אמרתי שאני לא אזכיר. בוא תכניס כדי
לא כמה יש שיתמודים
איתן, יש לך ניגוד עניינים.
13-8.
13-8. אני היחיד שהצליח... זה יהיה פחות מאחד, לא?
אולי נוכר שפאי של נעשה עוד.
לא, קודם כל הדבר הזה...
מה היחס?
מה עושים?
זה נותן את זה. אוקיי? שכחתי להגיד. תודה לתום. Okay, thank you to Tom, who went yesterday and measured the tiles for me. So, in our situation, S is equal to 42, okay? S is equal to 42, and L is equal to 25. Okay? So we need to do the calculation, we need to move everything around. But, okay, but first let's compute this sum. So,
It's 70 first.
מה? נדיה דינית. כמה זה יוצא?
זה 70.
זה? 70? ו?
זה פחות.
זה 49.
49 חלקי 70? אוקיי. So pi is going to be, רגע. So pi is equal to 25 divided by 42 times 4, right? Times 70 divided by 49? 49 is... לדעתי אגפים. So, pi is rational. שבעת אלפים חלקי מה?
יאללה, איך לגור זאת היום?
3.4.
וואו.
זה הכל בגללי, תדעו לכם.